Hello, boys and girls. And for the goodness of science. For thousands of years, mankind looked up at our rocky neighbor, shining in the night, and dreamed of walking on its surface. What would we find? Alien beings? Mountains of cheese? And if so, what kind of cheese? Blue, Gouda, Brie, white sharp cheddar, Swiss, baby Swiss? Dairy scientists could only speculate. But then, science and technology devised a plan to send a man to the moon. But how? A tall ladder? A catapult? Slingshot? Elevator? Actually, an elevator would have been a really good idea. I used to think so too, but then I considered how much energy would be expended merely playing the music during the journey. It is considerable. I hadn't thought of that. Yeah. Hey, what were we talking about? Music. No, before that. Going to the moon! Yes! Our dreams became a reality when we harnessed the power of Newton's third law. For every action, there is an equal and opposite reaction. And we built rockets.
Rockets!
A rocket is a fairly simple device. Inside, pressure is built up. If the pressure isn't released, the container explodes. But if the release is controlled, the result is propulsion. As the force of escaping gas goes this way, the equal and opposite reaction of the bottle goes that way. We will demonstrate with a balloon. The air in the balloon is under pressure. When it escapes, it'll go out that way. The equal and opposite reaction of the balloon will be to go that way. For every action, there's an equal and opposite reaction. For every force, an equal and opposite force. So, how do we turn a 2-liter bottle into a rocket? We have to build up pressure inside of our bottle and then let it escape. We're going to show you 2 methods. The first is no harder than pumping up a basketball, and it takes the same equipment. First, you just need an air pump that's got an inflating needle, like the kind you would use to inflate a basketball. And you need one of these. It's called a rubber stopper. See that needle? You've got to get your needle into the rubber stopper. You attach it to your pump. You put your pump in your bottle like so, and start inflating. I use this pickle tub to build myself a launch platform. It not only helps direct the flight, but it also catches all the escaping water, so it doesn't get all over me. I got a feeling I'm going to get wet anyway. As you pump, air is forced into the bottle, which increases the pressure inside the bottle. Eventually, the pressure is so great that it pushes the stopper and the water out. When they are forced out down, the rocket goes up. By adding air, we're adding pressure. When the pressure gets great enough, eventually it'll burst that cork off and send this thing flying. Rockets! Another method of building pressure inside the bottle is chemistry. We're going to combine vinegar with baking soda. When they mix, they release carbon dioxide. When the gas builds up, the pressure inside the bottle goes up. Eventually, it pops open the cork just like the pump method. The trick here is getting the baking soda and the vinegar in the bottle and the cork in, and the bottle on the launch platform before the chemical reaction is done. Here's a method we've used. First, pour some vinegar in the bottle. Now take a paper towel and pour the baking soda on it. Then we roll up the paper towel tight enough to fit into the bottle. Finally, slide the paper towel and cork in really quickly. Then stand back. Here's our baking soda. As soon as this gets in the bottle, baking soda hits vinegar, the chemical reaction begins. When the baking soda hits the vinegar, it starts releasing carbon dioxide. Carbon dioxide expands, it gets really big, really fast, and it tries to escape. The only place it'll have to escape is through this opening, which I'm going to put a cork in. So when the pressure gets high enough, the cork shoots off, the bottle goes off like a rocket. Let's see it happen. Nice! Nice! Remember, if you try this at home, don't stand here or your head goes away. Keep your head out of the flight path. Huh? All right, one more time. And the next thing you know, the impossible task of reaching the moon is within your grasp. Do the impossible. Harness the power of Newtonian physics and escape the Earth. Come on, Professor. Getting to the moon isn't that hard. I mean, it's not rocket science. Oh, wait, it's not brain surgery, right? Not if you follow all safety protocol. When you try this at home, here's a few things for you to experiment with. First, how much water will get you the best distance? Secondly, what amounts of baking soda to vinegar get you the biggest bang for your buck? And thirdly, what angle of launch gets you the best results? Let us know what you discover. And when you get to the moon, plant your flag, do a victory dance, and pick us up a few moon rocks for our collection. And for the goodness of science! The moon is pretty far away. It's the furthest that mankind has yet been. I used to think so too, but I found out it's not so. No? Where is the furthest mankind has been? Miami, Florida. Miami? What makes you think Miami's further away than the moon? Elementary, my dear professor. The moon is right there, but you can't even see Miami from here. Did you find that joke on the internet? Maybe. I think the laugh at the end of that joke is the furthest mankind has yet been. Because it took so long to get to the punchline? No, because I can't see myself laughing at it. Say goodbye, Professor. Goodbye, Professor.